So few things as far as the things to focus on. So you got to know how to take a derivative. So like, questions 9 through 14, obviously. So focus on questions like number 9 to 14. 6 and 7, definitely, you got to know that. 6, 7, and 8. Focus on those, okay? Now, here's another thing. You should focus on, go back, and if you haven't already done so, learn the intermediate value theorem. We'll talk about that in a minute. Let's see, what else? Be able to find the limit a couple different ways. Algebraically, like number 6, but also graphically as well. Like if I were to give you a graph and I say find the limit, you should be able to do it. Or maybe I give you or algebraically, like question number 6. Or maybe I give you a piecewise function and I ask you to graph it. So having said that, be able to graph a piecewise function. Be able to answer questions on continuity, like is this function continuous at x equals 5? Why or why not? What I will not have on the test, I'm not going to ask you a question on squeeze theorem. Some of you were wondering, I forgot about that. You're welcome. Let's see here, what else? Now, someone in my morning class was asking, how about velocity and acceleration? I mean, I wouldn't rule it out. It's pretty easy to remember, right? Velocity is just the derivative of the displacement function, and then the acceleration is the derivative of that. So it's not something that, it's something that you should know. I may or may not ask it depending on how I feel. Before I talk about the intermediate value theorem, is there any other general questions that you have for me? All right, we'll talk about the intermediate value theorem now. Oh yeah, how do you like your surface? Good? You like it a lot still?
Yeah, I do. I really do. It's like 2 years now since I got this, a little more than that, and it's working great. It's good.
All right, so if f is continuous on the closed interval AB, can anyone finish the rest of this for me? Just verbally, unmute yourself and just say what the rest of it is. You can't be looking through your notes and then telling me. All right, I'll tell you what it is. F is continuous on the closed interval AB, and K is some number between f of A and f of B, then there exists a C in the open interval AB such that f of C equals K. Don't worry, I didn't have it memorized when I was Math 151 until the test either. I know it now. If f is continuous on the closed interval AB, and let K be between some number between f of A and f of B, then there exists value C in the open interval AB, meaning in between A and B, such that f of C equals K. Rachel, is it cold in the place you're at?
Yeah, my room is really cold.
Yeah, my downstairs gets cold too, but now it's actually 70 today. It's not as cold as last week. All right, so let me explain this here. So there's the graph of f of x. Let's say here's f of a, and there's f of b. Oops. So there's f of a and f of b. Now k, remember, is a y value, the function value. So k is the value that's between f of a and f of b. And c will be the value that's between a and b. So the hypothesis for the intermediate value theorem to be met is that k, so f of x has to be continuous, and then k has to be between f of a and f of b. Then there has to be, then there is going to be some function, some value c in between a and b, such that f of c equals k. You could have more than one, but you're guaranteed at least one. Now, this is the case where k is between f of a and f of b. Now, if you remember the homework, there were some problems where we said, all right, there's a zero in between. So what they did in those problems is they had a situation like this, where you had something that looked like that. So in this case, your f of a was, let's say, a negative value, and your f of b was a positive value. And in that particular problem, they let, all right, let k equal 0 be, let k equal 0, which would still be between f of a and f of b. And in that case, c would be your right there, where it would be a 0. So this is your a, this is your b. So in this particular problem, a k equals 0, so that c value is where f of c equals 0, and that because k equals 0 in that case. So in this case, f of c equals k. Well, let me probably with k always, but f of c equals k, but in this case, k equals 0. So when k equals 0, it's a situation where, hey, if f of a is below 0 here, it's above 0 here, so there has to be some value c where f of c equals 0. That's how you're guaranteed a solution, 0. But it's not always the case where k equals 0. K could be some other number. It just has to be between f of a and f of b. Then you're guaranteed some value c that's in between. Now, when you do some of the homework problems, they just ask you to show, which means prove, that there's a 0. So how you did that is you showed that, hey, k equals 0 is between f of a and f of b, and you showed that, you explained how f of x is continuous, so therefore you're guaranteed to have some value in between a and b where you're going to get a 0. Now, you didn't actually have to find the zeros for some of those problems because it was too difficult to solve for it, so they just want you to show that there is one by the intermediate value theorem. Now, let me do an example again where I actually demonstrate the intermediate value theorem, and then I'll actually pick an equation where I can actually find it for you as well. Give me a second to look through my notes. There we go. Suppose f of x equals x squared minus 6x plus 8 on the closed interval 0 or 3. Show that the intermediate value theorem applies. And that there is a C on 0, 3, oh, sorry, such that f of C equals 0. This is actually the same example I think we did in class, but figured would I do it again. Okay, you guys, let's go over this. Hold on, sorry, I'm fixing something on my computer. All right, so first thing you want to do is, well, you can just say f of x is continuous on 0, 3. You don't have to prove it. It's a parabola, it's going to be continuous. It's a polynomial, all polynomials are continuous on the whole real number line, but you can just say f of x is continuous on the closed interval 0, 3, that's good. Now, let's figure out what f of a and f of b are. So f of 0 is equal to 0 squared minus 6 times 0 plus 8, which would be 8. By the way, in this problem, your k is 0 the way the problem is written. It's not always 0. In this case, it is. F of 3, that's 3 squared minus 6 times 3 plus 8. So you got 9 minus 18, which is negative 9, plus 8 is negative 1. So, since negative 1 is between k, is less than k, which is less than 8, k equals 0, then IVT, intermediate value theorem, applies. Now, I made it a particular problem in this case where it works out, and I actually, if I ask you to now find the zeros afterwards, or find the C value, you would have to say, all right, let's set it equal to k and solve. Two numbers that multiply to 8, minus 4 and minus 2. So you get x equals 4 or x equals 2. So the final answer is C equals 2, where f prime of C, not f prime, there was no derivative here, equals 0. Now, can someone answer the question of why did I pick C equals 2 and I ignored the 4? I will pick on a random person, and this random person, no, I'm just kidding. Let's see here. Okay. Oh, Dylan, I haven't heard from you in a while, or ever. Dylan Sims. Can you tell me why I picked C equals 2?
Because C is in the interval of 0 and 3.
Yes, exactly. C has to be in that open interval 0, 3. So it has to be some number between 0 and 3. Now, could you have multiple numbers? Yes, but you're guaranteed at least one. And in this case, we only got one. 4 is a perfectly good answer, but it's not a C value. It's a good 0, but yeah. Does that make sense? All right. Omar, how are we doing? Good.
Which one?
You, the Johnny. Is it the Johnny? Is that how I pronounce it?
Yeah, and I'm doing fine. Thanks for asking.
Were you one of the students that said you're out of the country right now?
I'm out of before, but I am back now.
Oh, no, sorry. That's my 1 o'clock class. I had a couple students that were outside. I had well, in this class, Lauren was in Mexico, but I had students further away. I have one in South Korea, and I have one in Kuwait. Last semester, I had a student in Japan. So I'm definitely now Mr. International Speaker. All right. We just got to get more continents, though. It's all in North America or Asia. So are we good on that? Okay, so let's talk about the next topic here. Well, what else did I want to talk about? Give me a second here. Any particular questions on the homework that you want me to do right now from 3-4, 3-3?
Professor,
Yeah.
will you ask us questions that are like on our quizzes, or are they going to be completely different because you're not going to test us on that again?
Well, I'm going to ask you like find the derivative using the limit definition. So yeah, it'll be a different f of x, but like I might say, hey, find the derivative of f of x equals, let's say, x squared plus 9x. Can you find the derivative of that using the limit definition of derivative? You guys want to practice that right now? All right, find the derivative using the limit definition of derivative. And you should be able to do this in 60 seconds. 59, 58, 50. No, I'm just kidding. You guys all got the question down? I'm going to exit this here. X squared plus 9x. You got it? Use the limit definition of derivative. Okay. I'm going to look through my notes here real quick.